Today we're going to solve Leetcode 292 Nim Game. So the question says that you are playing the following game with your friend. Initially there is a heap of stones on the table. You and your friend will alternate taking turns and you take the first turn. On each turn, the person whose turn it is will remove 1 to 3 stones from the heap. Okay, so you can either remove 1 stone from the heap, 2 stones from the heap, or 3 stones from the heap. Finally, the one who removes the last stone is the winner of the game. Okay, so what the question asks us to do is that given n, which is the initial number of stones in the heap, we should return true if we can win the game, assuming that both you and your friend play optimally, right? And if we can't win the game, then we should return false. That means if our friend wins the game, even though both we and the friend play optimally, then we should return false. Okay, so let's try to see how to solve this and gain some intuition about this. So just by reading the question, it isn't actually easy to figure out or like get a lot of intuition about what the solution should be, right? So how do we approach this question then? A general practice in problem solving is to start small. Okay, so let's take the smallest example possible that we can think of. Let's say that we have 1 stone in the heap. Okay, so whoever has their chance okay, so let's say initially there was 1 stone in the heap. Okay, so whoever has the chance initially can just pick up this stone and win, right? So whoever has the chance will win when there is 1 stone in the heap, right? Now we know that initially the first chance is supposed to be ours. So if initially there is 1 stone, then we have the first chance and we can win, right? Similarly, if there are 2 stones, we can pick both of these together and again win, right? And if there are 3 stones, then we can pick all these 3 together and win, right? So that's well and good, but what if there are 4 stones? Now we know that we can't pick all 4 of these and win, right? We have to pick either 1 or 2 or 3. Okay, so what happens when there are 4 stones? Like, what are the different possibilities that can happen? The first thing we can do is that we can either pick 1 stone, right? And if we pick 1 stone, then our opponent gets the chance and he sees 3 stones on the table. Okay, so now he can pick all 3 of these and our opponent or our friend can win, right? If similarly, if we take 2 stones out of the heap, our opponent will be left with 2 stones and it will be his chance now. Okay, that means our opponent will be seeing this kind of a situation that he has 2 stones and it's his chance right now. Okay, so again he can pick both of these and win, right? And finally, the only other option we have is to choose all the 3. Choose the 3 stones given in the heap, right? So in this situation, our opponent will have his chance now. Okay, and he'll see 1 stone lying on the table, right? So he can pick that and win. So in all the like, no matter what I play, if it's my chance when I have 4 stones on the heap, okay, then I'm going to lose. Okay, so whoever has their chance when there are 4 stones on the heap will lose. Okay, so that's a interesting thing that we saw. Now let's think about what happens if there are 5 stones. Okay, so if there are 5 stones, okay, and let's say it's your chance again, the first chance. So what can you do? You can pick one stone, right? And what will happen is that after you pick this one stone and remove it, it will be your opponent's chance, right? So he'll see 4 stones on the table now. Okay. And we know that if there are 4 stones on the table, whoever has their chance is going to lose. Right? If they see 4 stones on the table and it's their chance to pick now, they will lose. So our opponent will end up losing no matter what he does. Right? That means we will win if there are 5 stones just by simply removing one stone and leaving our opponent in a situation where anything he does will end up in him losing. Okay. Similarly, if there are 5 stones, we can take out 2, okay, and leave our opponent in a losing situation again. Okay. And if there are 6 stones, we can take out 3 and leave our opponent in a losing situation again. Right? But what happens if there are 8? Okay, what happens if there are 8 stones on the table? We can't get our opponent to a losing situation now, okay? Because we can't remove all 4 of these stones, right? We can only remove 1, 2, or 3. We can't remove 4, right? So if I remove 1, okay, I'm going to leave my opponent in a winning situation, right? If I remove 2, I'm again going to leave my opponent in a situation where he can win if he plays optimally. Okay. And if I remove 3, then again my opponent will be in a situation where it's his chance and there are 5 stones on the heap. So if he plays optimally, he'll be able to win, right? So I see that when I get 8 stones, I'm again going to lose. Okay. And we see a clear pattern emerging here that if there's 1, 2, or 3, I can win if I have the first chance. If n is 4, then I'll definitely lose, right? Then if n is anything between 4 and so if n is like 5, 6, or 7, then again if I have the first chance, I'll win, right? But if n is 8, I'll lose again. And this pattern keeps following, okay? So what we see is that for every kind of multiple of 4, okay, we end up losing. Okay. So if the initial number of stones is 4 and initially it's our chance because that's how it's given in the question, then we lose. If it's 8, then we lose again. Okay. If it's 12, we lose again. Okay. But if it's any other number, okay, then we are going to win always. So that's it. That's all that this problem reduces to. Okay. It was kind of like a riddle or like a brain teaser to figure this pattern out. That initially, if you have some number of stones that is a multiple of 4, okay, then you're going to lose. That means if n mod 4 is 0, where n is the initial number of stones on the thing, then you can't possibly win, no matter how you play, right? But in all the other cases, if n mod 4 is 1 or 2 or 3, you can win. Okay. So this is all we have to code up now, and coding this up should be fairly simple. Okay. So let's go and implement that now. Yeah. Okay. So the code for this should be fairly simple, right? The only situation in which the person whose chance it is loses is if there is a multiple of 4 number of stones in the heap. right? So because it's our chance first, then we'll only lose if n is a multiple of 4, right? Which means n mod 4 is 0. Okay, if n mod 4 is 0, then we lose, so we should return false, right? And in every other case we can uh, end up winning. Okay, we have a strategy that lets us win, so else we return true. Now that's it, that's all that the code is. So let's try to run this. Great, so it works on this sample case. Let's submit it now. And great, so this code obviously works. It was a really short and simple code. Thank you for watching the video. I hope it was clear, the algorithm was clearly explained, and this was just kind of like a fun brain teaser problem. So hope you guys enjoyed it, and keep practicing.